Hi, this is Jordi from Agents at Work, and today I have the pleasure to interview Nimrod, CTO of Baz. Hi, Nimrod.
Hi, Jody. How are you today?
Doing well, thank you very much. So, I think that you are in Israel right now. Israel is really famous for deep tech companies. Can you tell us a bit about Baz? What are you building?
Sure. Buzz is hopefully the company that will build the best platform that understands your code base. But for now, it's just the best AI code review agent in the world.
Okay, so the idea is that it's code related. The mission is to be able to say like, listen, all the code it's understood by this platform, and the product today it's about reviewing code.
Right. I think the problem that we started with was um, it's hard to understand the code base, even for developers or for software engineers who are working at it every day. And in the tools that we had pre-LLMs, pre-agents, we could do sorts of static analysis to connect the dots, but we couldn't really understand semantics. We couldn't understand meaning. And that's the addition that LLMs brought to the table that allows us to build these great products that really understand.
Okay, so this is actually a really good insight for starters. Pre LLMs, we had some tooling to understand code, but it was basically like on type theory and a bit of static analysis. And with LLMs now, we're able to understand code at another level, it's semantics. And this is thanks to the intelligence that the LLM bring to the table. And you were like, well, this needs to be connected because it's a big jump from the older technology.
Right. I mean, me and Guy, my co-founder, who's the CEO of Buzz, we've been working at BridgeCrew, that's the previous company, which Guy also was one of the founders. And it was based on AST. It was based on analyzing statically code, whether it's Terraform or CloudFormation or stuff like that, and identifying key elements, key strings, key things that are bad from a security perspective. And approximately 2 years ago, when ChatGPT came out and we were writing happy birthday gift cards and sending it in German to our friend who can now translate it back to English, we realized that something here really understands what you're writing. And it's not just the connection between different symbols is the name for the string that is you actually write. But then, of course, I mean, like everything, if you just dump the code in, it will get confused, it might hallucinate. So we realized that the connecting the AST with all of the preciseness and the cross-file references together with the actual code will could possibly, as we thought back then, and I think it proved itself pretty good. It actually connects into something which is bigger than just summarizing the code. It can understand flows, and it can point at things that might break if you change something else entirely because it understands the connections.
I see. So you said that you have a co-founder, and he already had a company before, and you worked there too. And it was about some kind of dev tool. Can you tell us a bit about this?
Sure, sure. So the previous company's name was BridgeCrew. The company was based on an open core platform. So we had an open source. Uh, they have an open source called the Chekhov. It's in GitHub. It has thousands of stars, hundreds of millions of downloads. And what it does is static analysis on infrastructure as code mainly. And we built an entire platform around it with dashboards and remediations and suppressions and stuff like that for the enterprises to really, make a profit in the end of the day, but also contribute to the community. And it was solely on AST and static analysis of code. That's what we built out. Uh, After approximately 2 years, we were acquired by Palo Alto Networks, which is it's a big event for a company. It really changes a lot of things. Um, I was at the time leading the team that built the security engine, so that means the open source and the container that ran the open source within the platform. There were a lot of other guys who did incredible stuff like, packaging it as a Circle CI orb and building the web app and, managing the database and the suppressions in the lifecycle. It's very complicated, but essentially I ran the team that built the scanning engine. And after the acquisition, we kind of transitioned from cloud security to code security. So the team exploded into a group of 23 engineers doing all kinds of security scanning. But the initial product was just find badly configured S3 buckets or RDS databases. It's much easier to find it in code before it gets deployed to production. And I have many war stories if you want to hear. But I mean, it's crazy how many stupid mistakes developers can do, not because they're stupid, just because they're not aware of all the configurations. And today, with the age of AI and the fact that the AI auto completes your S3 bucket configuration, I'm sure it only got worse. Although I haven't been doing this for a year, I'm sure it got worse.
Yes. I am guilty of having broke production more than once because of misconfiguration. And not only like when I click and point to stuff, but actually as infrastructure as code. And something that always triggered me was when they were like, well, in the docs it says it clearly. You need, every time that you add this thing, you need to add this other thing too. And like, okay, so why does it allow me to put only one of them? Like if they always go tight, or like you need to put this other one with this other value for sure. Okay, so make it happen automatically. Like, or I need some kind of check. So your company was helping with this, no? Like usually static analysis, like people think about code, but we can also use it as infrastructure. So you were able to read the symbols and say like, well, is this well configured? I guess that you had a lot of logic for every kind of cloud.
Right. Every kind of source within every kind of service, within every kind of cloud. So it's like three levels of specificity.
I
And
see.
and in Azure, it's even versioned according to the date of the year. So you have many versions of the same resource. It's
I see. And
horrible.
mainly the kind of users were enterprises for this, like people who say like, well, I have a lot of infrastructure. I need to handle this somehow.
Right. So we had the open source or the small scale companies that they were just starting fresh. They would build Terraform because that's the fastest way to go on AWS and remain immutable and safe. But the big customers were obviously the big companies who have teams that build Terraform modules and then teams of infrastructure engineers or DevOps or DevSecOps or whatever you call the title, who actually use only the internal modules to build up their own infrastructure for the different services. And those were the companies that were the big customers for BridgeCrew and later within Palo Alto Networks.
Okay, yeah, I understand why Palo Alto Networks was interested in this kind of product. Like it really like targets their base customers. So they acquire you, and then as soon as that, you jump into Baz, or there was like some time that you spent inside Palo Alto Networks too.
So I spent all in all 2.5 years in Palo after the acquisition. It was a very, very fun time because when we were acquired, I led a team of 5 engineers. We're doing only infrastructure security, and Palo said, "Listen, you already have access to code. Do code security." So my team, I already said it, but it grew a lot into like 23 engineers, 3 teams doing multiple stuff. And the amazing thing about Palo is it's a machine. I mean, when we were acquired, we had 30 companies who were customers. Some of them were big, but not a lot. And most of them were like mid-sized or growth stage startups. And then we integrate into Palo Alto. It takes time, okay? It doesn't happen in 3 months. It took like 9 months. And then I remember they flipped the switch and we went from 30 customers to 350 customers within 3 months. And I mean, it's always funny when you build a startup, you say, I'll handle scale when I get to scale. And then they just flicked the switch and we were at scale and everything was coming, falling apart. It was fun times. And I really remember that like 3 or 4 months after we were really integrated into the big product, the SVP came to visit us. And we were a startup, full CI/CD, everything goes directly to production. We'll test it later, it's all right. We're doing innovative stuff. We have very fierce competition. So he comes to visit and he says, listen, guys, your product has the fastest adoption in the history of Palo Alto Networks acquisitions. It's amazing. Um, but you have to release slower. And we were shocked. And he tried to explain, that Palo Alto has a big machine. There are sales engineers and salespeople and marketing, and we have to build out the not the theme, but like the message, and it has to connect with everything else that we're building here. And the fact that you're releasing 5 times every day, it just makes it completely uh, uh, unmanageable. And I think that was the moment that things started going too enterprisey for me. And after 2 and something years in Palo, a guy talked to me. A guy and I go back 17 years, so it's a long time, but we didn't work together until BridgeCrew. And he said to me, "Listen, I'm starting to feel the urge to start something new. What do you think? And we started talking about Buzz, and that's how we opened Buzz almost 2 years ago, August 23.
And that's amazing because there is a lot of insights here that many people that are first-time founders don't think about it. But distribution matters a lot. Many times, like more than product.
It's
And
amazing.
then you can really feel like how you can have an amazing product. You're doing product growth. You say like, oh my goodness, like it's so crazy how fast we work. And then many people this like they don't want to be acquired or anything because it's like, well, what's the value they will bring? Like I'm not going to sell because yeah, that's money today, but why would it be with the product? I want to continue building. And you're like, well, if you're acquired, like there is like some cons, like for example this, like you need to build a bit slower because you are targeting a lot of people that maybe not as passionate about the product, but they are actually going to deploy it at scale. And you really feel this idea of I switch something and goes to like to scales for real. This is something that now, even with AI, you can see that there is a lot of startups that are being growth, and there is some adoption into enterprise, but they are not really like pushing for it. And I would imagine that few years in, we're going to see how these enterprises start like acquiring other companies. And again, like for many people who are first-time founders, they don't try to think like this. Nobody wants an exit, and you're like, well, actually, it may be the best for the product, for you, for the company, for everything. So it's amazing that you already did that path and you have seen it firsthand.
Thank you. Thank you. Yes, it's I mean, when we founded Buzz, we thought about, as founders, are you looking for a quick exit or are we building something big? And Guy's answer and my answer was aligned. It was this time we want to build something big. Now, that doesn't mean that if there's an opportunity, you won't take it. But yeah, I mean, we've built something and then 2 years in, we were acquired. So this time we're trying to build something really big.
And then, of course, like coding is like the biggest thing to do right now,
Yeah.
especially on agents, because many people have talked about agents for a while. There is no clear definition yet, but you can see that many of them do not work. Like people call agents to kind of like just some specific workflow and things like that. But there is like two that seems kind of sticky. The first one is like deep research. So this idea of I ask you for something, you go and search, and you can iterate as many times. And the other one, it's in code. You go out there and like work in the code of this. So you already have all the experience about like working with code before, even if it was infrastructure, and then later on at Palo Alto with real code. Um, you kind of notice this thing of LLMs are really good at semantics. There is something big here. Let's edit it, and then you jump directly into review, or how was the logic?
So we didn't jump into review too quickly. We realized that there's something here that we can build that really understands the code base. Because we have the understanding of what this function does, and we, from the AST, can bring into the context all of the definitions and the references that are relevant to kind of understand the entire flow. And we just talked with a lot of people. We talked with around 100 VP R&Ds, CTOs, architects, entrepreneurs in the dev tool space. And it was approximately when GitHub Copilot ruled the coding space. And we said, we're not going to fight uh, Microsoft and GitHub. That would be foolish. I mean, look at Cursor. They came after us and they did really well. So I guess you can always challenge the incumbent. But we realized it's going to be a very dense market, and we looked for something right next to it. And what we heard from most of those people was, listen, if coding agents is solved, and as a founder, when you start out, you need to think what will happen in the next few years, not what needs to be done now. And if coding is solved, then we will need someone to review all of this code. And that's why we decided to do code review as the first implementation of the technology. So we understand your code base the best in the world. What do we do with it now? Right now, we're doing code review, but we can go into other directions once we uh, feel we've completed this objective.
Perfect. For people who are technical but don't know what an AST is, what is it? Like you said, like you use this in your product for stuff. But how does it help and where does it come from?
So stands for Abstract Syntax Tree. When you write code, for example, Python, right? When I want to declare a function, I write def space, the function name, let's say foo, and then I open the parentheses to define the parameters, right? And then the parameters can be bar of type str, and then I close the parentheses and I do colon. Now this specific order or structure can be defined as a set of tokens that the function understands. So def is a function declaration. And each function declaration has a few tokens. And that's like the tree. So you have the function declaration at the top, which is called def. That's a symbol. And then within that tree, right beneath it, you have the function name, which in this case would be foo. And then it also has the function parameters. So those are two children of the function definition node. And that's how you create a tree. Slowly but surely, you get into very complex trees. Um, I mean, if you're technical, you know about variadic functions and all sorts of spread operators that are syntactic sugar for something really complex. The ASTs do not have syntactic sugars. It's all in there. And the crazy thing about ASTs is they can actually be much bigger than the code, because for us, the location holds information that the AST loses. So it has to make up with more nodes and more indentation and more tokens.
So it has been many years since I was at university working on compilers. So just like let me know if I understood this properly. We have the code that is what people write today, and then at the end I have something that is executing. So in the middle, like one of the first phases is like, well, we have some kind of software that takes that code and parses it. No? So it needs to understand what I am explaining there. Then after it's been parsed, it can perform some optimizations. Then it has to output some binary code that is like the program itself, unless there's an interpret, but let's keep it simple. And
Yes.
then when I am executing it, that binary code goes and there is a machine, like there's a runtime that takes that and says like, well, how does this go inside the machine? So
Right.
the AST is at the beginning of this process. It's this idea of I take the code and I have to parse it in some way that
Right.
it's like a more structured thing than the language syntax itself.
Right.
And
Right.
that's what you are leveraging in your product.
Yes, and I want to shout out a really cool open source project around this area. I mean, every compiler, the Java compiler, the C compiler, every compiler does it slightly differently. But there's a really, really good open source project called TreeSitter, which supports using Anther or all kinds of other things, basically 138 different languages. And if you use that, of course, every language has slightly different semantics. So one has a function, another has a method. And I don't know if you wrote code, Go code, but that has receiver functions. So it's
Mhm.
slightly different, but you get the same format and you can work with that. And that's what we love.
That's great. So for people who have never worked on this, like the AST, it's a concept that is generic. So all languages have it. Like every time that you have code, it needs to be parsed on this. But then every compiler has like different kind of nodes. And so you have the abstract thing that it's the same, but it's not the same for all of them. And then
Right.
Tristitter, it's some kind of Rust library, if I'm not wrong, that somehow it's able to say like, well, what's the generic thing that they have in common? And let's add some details for each language. And then your product can say like, well, I work with JavaScript, I work with Python, and I work with Golang, without having like some heavy investment from your side. Like you get like all the parsing, it's already done by an open source library that you
So
can
I would
leverage.
need to know that I'm looking for function in Python and method in Go or something like that. But besides that, it will be exactly the same. Right.
Exactly. Okay. Perfect. So that is something useful. Shout out for the people creating the Sitter. I know many companies that are leveraging it and products, so it's great.
Yep.
Now, why did you use the SAT? Like, why you decided to do this? What kind of things does it bring on the table that allows you to separate from, like, like many people may have seen LLMs and say like, yeah, I put code in and it's able to recognize it. Like it already knows the semantic. What does the AST bring on the table?
So let's start with talking about LLMs and the limitations. I don't know if everybody here has heard about Git ingest, the GitHub project Git ingest, or about DeepWiki from Cognition at deepwiki.com.
Mhm.
It's two sites that basically ingest your entire repository and can give you insight on top of it. DeepWiki is a web app, and Git ingest just takes all of your GitHub, ingests it into one big markdown README file that you can send to the LLM. Now, the problem here is that even the best developer I know, if you just let him read so many Python files or so many, it's not just Python, a repository has YAMLs and configs and all sorts of things, you would not remember much. You would maybe do a good part if you along while you're reading kind of summarize things, but it won't come out too structured. And what AST does, and that's what we built, or that's the core premise of every security product that builds on top of ASTs, is it can understand the flow. Because when you write code, you write it in files and directories, but it's actually a tree. It's actually a graph where one function can call a different function that might be in a different directory or within the same file. It doesn't matter. For code, everything is a graph, and ASTs can traverse that graph much better than just, uh, uh, piling all of your files one by one and then sending them to the LLM. So consider this. If I use git ingest and then ask a question in my repository, he reads my entire repository every time he needs to answer my question. But if I give him a function and ask a question about that, and using AST, I can bring the definitions and all the things that it uses, but only those into the context, suddenly the LLM sees everything much more clearly because it has only the things that it needs. And it doesn't have all the noise that comes with the rest of the files.
Nice. So here with SAT, you can do something that it's between just reading the code and actually like when it's executing, that it's this idea of you are able to what a person does. Like every time that I need to add something and someone asks me something about code, I need to kind of plot what is going on. Like, okay, this function, call this function with these parameters.
Right.
And now here, what it's arriving, where did it come from? So you're able to have some tooling that it's able to do all these at
Right, the
static
AST,
time, so it doesn't have to run.
right, the AST traverses the code for you, so you can kind of take a tour, see what's actually connected. Um, a funny story. We tried to scan. We have customers and POCs and open source repositories that are connected, and then someone connected a repository, and for one change, the AST pulled in 5,000 functions and classes, and then we realized that it was just the main entry point that he changed something. He added something in the function of the entry point, so he just pulled into the context the entire application. So we had to say, okay, maybe it's connected, but if it's not critical, let's not add it because it's a crazy amount of context for basically nothing needed. If I change the main entry point, I don't need to see anything else.
I
Um,
see.
so it's not a solution. It's a tool that you need to use.
And how does the product right now look like? Like people who are using Baz, like do they have access to the abstract syntax tree, or they just add some kind of bot to GitHub and then like writes issues? How does it work?
So people love to geek out, but I will say that personally, I love software and products which are super simple. Like I love to hear about it and read about it, but if I need to configure it, I will just not use it ever. So that's why Baz is very much close to what you suggested in the second option. It's a GitHub application that you install, it scans, it identifies all the different modules that you have within all your repositories, and then the connections between the files, the functions, the enums, the structs, whatever you define. And that way, whenever you make a change and open a pull request, we can identify what has remained the same, what has changed, and what it is connected to, kind of summarize what's going to happen and what might be affected, and then also do code review on top of that. But to do a really good job here, it's not just the code that you need within your context, and we can dive into it. I mean, in the next question, with all the things that the developer holds in his mind, which are not just the code that are important here. But if we stay on the code for a second, it's not just the diff and the things that are above and below the functions from a graph perspective. It's also understanding the potential impact. And if maybe I messed up an API endpoint or I changed an API endpoint and I don't know. Maybe this thing is being saved to an object store like an S3 bucket or a MongoDB database. And I'm changing the schema and now things are not going to be saved correctly because I'm removing a field without understanding that. So all of these things need to come into the perspective of the change and not just this line was deleted, this line was added. Is it good?
Okay, so Bass has some kind of superpower already on the code level, but as you mentioned, like there is much more around than
Right.
just code in a product.
Right.
So here, Bass will not only check, well, yeah, these changes don't break this other call to a function, or like it's called in this other place and you didn't update it. This is something that sometimes a type system may catch, but maybe something like Python, like with Bass would say, like, listen, you updated this declaration. This one is called here wrong. And it's really good because it's not only about like the number of parameters or things like that, but also the types that it's being called, and then Baz could code that. But on context, that it's reality. Like context is king, and it's very much needed on anything LLM related. How can Baz help that? Like, what kind of context does it have, and where does it get it from?
So, um, I mean, I believe that context is the only mode that you can really create in today's AI landscape. Because if it's a prompt, someone will hack you and extract the prompt. And if it's the model, a new model will come out that does even better than you in 6 months. So context is important. And the way we approach it is we try to build the same context that we as developers have when we work at a company for a long time. When you work at a company for a long time and you look at a specific pull request, it's not just the diff that you see. You understand the services that are being changed. How will it be deployed? Is it one step or is it a few steps? Which CI or how does it behave in testing environments? What is the requirement? What are the tickets? Maybe I was in a planning session. Maybe I heard about it in the daily. I know what I expect to see in general. Maybe this guy talked to me in the corridor if you work in an office and you hear things. And all of that context is important when I approach the review of my peers. And we try to build it ourselves as well. So that means that when we do summaries or code reviews, we don't only look at the diff and kind of search around it. We try to add the context of the module or the project that we are reviewing it. Maybe it's a front-end based web app built in TypeScript with Vite. Maybe it's a Java SDK that runs on mobile. I don't know, but even knowing that helps me as a person, so we try to give it to the LLM. But it's not just that. We also integrate with Linear and Jira to kind of grab the requirements, which are also important. And now, I mean, I have a great example that I always share when I actually do a demo. We had a pull request that tried to improve the performance of the graph building. Graph building is very heavy. So we opened a ticket. This is the problem. Let's fix it. And one of my most talented engineers actually took it on, and it was a series of pull requests. But in one of them, we had a loop that goes over all of the edges in the graph. So all of the things that connect different points in the graph. And if something was not found or bad or missing, he broke the loop and started from the beginning.
Mhm.
So Baz caught that, and in the code review comment, it said, listen, it's kind of heavy-handed, and also it might improve performance if you do this and that. And the fact that he was able to say it would improve performance, it because it got that context from the ticket. It's really nice to see these kinds of things. So that, and we also read CI logs to understand what could break and what could really work. So, I mean, context building is an art, and it's not talked about enough. So, I stress this out.
So, for what I'm hearing, usually how I would tell people, I would say, like, listen, this is really useful. It's like having a senior engineer that reviews PRs for you. But actually, when it has all the context, we don't call it senior anymore. We can call it like a staff engineer. So it's actually someone who knows not only about like, yeah, I am a good programmer, but have the context of the company, of the products, and actually can catch all this stuff. So that's pretty amazing. Um, have you seen like any improvement, or how have been the improvements since you started? Like, what kind of things did you wanted to build and the models were not good enough versus where we are at now? That you say like, wow, because this is what you just shared. It's pretty impressive. Like this idea of, you should do this, and actually this is the problem. All from code. It's amazing.
Thank you. Um, So over these past 2 years, I think the biggest point of improvement was when we really tested out Claude Sonnet 3.5 when that came out. That was a beast model that it took, I think, almost 2 years to generate a better model at coding. Until then, using GPT-4, GPT 3.5, it was all right. It found things, but it hallucinated. I mean, we had a bug way at the beginning. Okay, MVP, no customers, no, just internally we're testing this out, and we're trying to generate the first reviews. And we had a bug where we sent a field called diff with the entire code diff, and then we expected to get a code diff parameter. So it was a different name. So we basically sent and nobody received on the other end.
Mm-hmm.
But we got summaries and reviews, and we were like, what's going on? So we take a look at the LLM tracing, and it just, since it has a field code diff which was empty, the LLM just decided to, I don't know, load from memory a pull request in Python, which we didn't write back then. It was just Rust. It loaded a Python pull request and then just reviewed it and gave us a review for it or the summary for it. It was amazing. I mean, we did a pull request that changes some log and we got a summary about a new service that was being added. It was hilarious. So hallucinations are a big thing that I feel models have really improved at. Although there's still some places for improvement, but it's nowhere close to where we were 2 years ago.
And for people who are building, maybe not in the code review or code even space, but that they have this idea of, well, we have some kind of system that takes LLMs and then it has to produce results. What would you recommend them to build as a guardrails? Like what kind of like monitoring you have added there? When you push a change, you just have to like stick to the screen to see like when the new requests come in, what kind of new hallucination it's in, or you have like something built in to make sure that these things are caught before it pushes production.
So when you build the first things, basically you release them and then you look at what the logs say. That's how you build the first things, guys. Let's not skip ahead of the ball here. But I mean, once we started having design partners, which are basically pre-customers, okay, they're people who want to pay for a product like yours but are not there yet. We realized we have to step up our game. And for that, we did two things. One is we integrated, we selected Datadog, it doesn't really matter. We selected, it's all based on open telemetry. So if you use Sentry or New Relic or even the raw open telemetry stuff with Jaeger and Grafana, it should also work. Kind of understand what the inputs are, what the outputs are. And once you have that, you have to build a benchmark. And what is a benchmark? That's like a heavy topic to talk about, but without running before you release every change on a big data set, which you have tagged, which is work that engineers hate, and I hate it, but it's very important. You won't have the confidence at releasing. And the craziest thing about LLMs is the benchmark would not pass at 100%. Okay, this is not a test. And LLMs are statistical machines, so that means that I mean, we have benchmarks that aim for 80 to 90%. We have benchmarks that aim for 40 to 50%, because that's how good the LLMs will get you for now. And we're hoping to see the models as they progress, the percentages become more and more deterministic and towards the 100%.
And where does this the Baz agent? What is it trigger? Like where does it run? Is it in your infrastructure? Can I run it locally? Like like do I need to create a PR for it to actually like trigger? How does that work?
So the agent itself is not that heavy, and it's a Python container that you can run anywhere. But to connect with the knowledge base and the Git server to fetch the code and the AST that is saved in the Postgres because graph database suck. It's really not something that you can deploy easily. We have it in a Helm chart, so if you want to deploy it on-prem, it's possible, but it's not as easy as just a single container Docker run and you have it working.
I see. I see. Yeah, I just feel like context is also the mode, and it's the mode because it's not easy to build. If it was easy to build, I would say like, okay, so just like have another system that just does it. This seems that it's not going away. Like this is some kind of hard problem.
Yes.
And we call it the agent, like the Baz agent. So something I would like to know is like, what's an agent for you?
So for me, an AI agent is a process that decides on the flow on its own. It has maybe a limited set of options, more than one, at least two, but it can decide what it needs to do and then act on it. That's what makes an LLM an agent.
And right now, for the set of tools that your agent has, you have to build them, each one of them. So it has to be like a Baz supported integration, or I can bring mine with, for example, like MCP. This idea of I bring context from linear, if I don't use linear and I have something custom internally, can I bring context to it?
So not today, and I think the biggest worry for me as a CTO is security. I mean, we've had people just connect and um, open a pull request, and the difference the pull request is write me a React component that does blah 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 blah, and it would expect the LLM to just grab that and do whatever. I mean, do whatever he says and not what I asked it to. So um, it's crazy how many bad actors, or not bad, just mischievous people who want to try and beat the system. So we don't allow, just like we don't allow making HTTP calls to whatever site you provide. But I mean, we build integrations really fast, especially since FCP came out. Adding a new tool is super easy. And then the LLM can decide, this is a ticket. Which ticketing system are you using? It's a step. And then there's a deterministic API that says linear. And then the LLM says, okay, let's fetch the ticket from linear. So it has to be structured somehow, but the agent decides what to do.
This makes a lot of sense. And, like many times when we talk in abstract, we imagine that the agent can do everything. And then the people that are really like putting like building it, it's like, guys, like there is a lot of challenging things here,
Oh,
starting
right.
from security to, like complexity. So it was not just like, well, can you build this? It's like, yeah, we can build it, but. And it's really important because as a CTO, you are the one that has the conversation with the client and actually knows. Yeah, many people say that they want that, but if we build that, that's not what they want.
Right.
So it's really good. Like this podcast is mainly to to be able to share this with third party people, so they hear it to it and it's like, oh yeah, every time that someone asks for something that does everything, I need admin admin access to
Root
everything.
access to everything.
That
Yes.
makes sense. Perfect. So usually I use close with a couple of questions. The first one is always like, what are people doing today that you would like to see that they stop doing in the next 6 months? So what's something that people maybe like they don't know that we already like past that phase, or simply that it's a bad practice?
So I think I mean, there's a start of a movement in that area, but I think that um, using one tool, which has an LLM, it could be Cursor, it could be something else, which connects with MCP to all of your other apps and saves you the command tab in Mac to switch to Windows and just grab everything and put it in one place, is I mean, it has to be the future of how you work. Because today the fragmented way of, I mean, I don't know how many Chrome tabs you have open right now, but I'm in the tens, and there's no reason for me to have this many tabs when I hopefully do code and meetings, which is like maybe 4 tabs. Um, so that's what I would really love to see, like the centralization of an LLM that basically wraps your other tools.
Okay, so something that already has like the right security levels, and then you are able to everything is interconnected, but it could be like an API gateway. Like when we have many systems, we don't just like splash them over the internet and then everyone has its own stuff. It's like, well, we put a gateway in front,
Right.
so we need the same thing for integrations and LLMs.
There's lots of security startups around this area, but I mean, I'm putting the security for this for the minute on the side and saying I would want for the comfort of work to have one interface for everything.
I see. So that's what you would like happening. Like people already like starting using it. What
Yeah.
would you like to stop seeing? Like, there's anything that people are doing today that you don't feel comfortable, like from your security background or even like from the software engineering point of view?
Um, so you would say it's kind of pesky, but I think that whenever a new model comes out, I remember when Sonnet 3.7 came out, and then Sonnet 4 came out, and OpenAI's 4.0 Mini and 4.0 Mini Nano. I mean, every small model causes the entire ecosystem to say, we now support a new model. And I mean, it's a configuration. I don't know if it even works better than the previous model. It was released today. Please. I mean, models for me are just the details. We don't talk about the models that we use with our customers. I mean, if they ask, I'll answer, but it's not your concern which model I use because I own the quality of my product. And if I use some kind of IDE. I don't want to be able to select. I want to ask the question and let the tool decide the right model for me.
That's actually really funny, and you can see it on like as a PR on Twitter all the time. And it's
Yes,
extremely annoying. Like when people say like, well, like OpenAI just released this publicly and we added a new line that says like O3.
right.
So, like now you can access to it and you're like, okay, yeah, thank you. I don't know if that's going away. I also wish it would. But I guess that people just try to get attention. So they're going to do whatever happens to, like, oh, ChatGPT released this. We need to do something for it. Um, so actually, it looks in crescendo. I hope that you are right, and it disappears in the next
Yeah,
6 months.
thank you. I hope so too.
Perfect, Nimrod. So for closing, like I have a question that is like, how do you see the next months at Baz? Like, what are you excited about building? And in this long run, until you are the company that understands better your code, how do you see that transition?
That's a great question. So when I look at the coming months, I see us focusing on code review and kind of cracking that nut. I would want to be a tool that people trust to approve simple pull requests and kind of pull in the architect or the senior engineer or the relevant engineer within the team if I'm not sure about it, but kind of just lower the amount of code reviews that we do today. That's I guess what we are trying to solve now. How do I see this connect to the larger vision? I think that once you understand the code base and you understand what each change means, um, CI suddenly becomes a no-brainer. I don't need to write long batch scripts to decide what needs to run. I don't need to write long batch scripts to understand what needs to get packaged into the Artifactory or needs to get deployed. Suddenly everything is just, I mean, implicit within the code. And that's I think where we're aiming to be at a point where you need to work less as an engineer because you write stuff and the system understands you. And when I say understands, it's not just code, as we talked about. It's the entire context of what the developer works with and how he gets his tasks and what does it mean for his task to be done, which is much bigger than just the code.
That makes a lot of sense. And what I really like about how you are focusing on a problem today is the idea of we can use it today, but on top of that, it's perfect for what it's coming. Because if you see where we are moving with cloud code, with codecs from OpenAI, agents in the background in Cursor, we're going more and more to I create tickets and things needs to happen. And then what they do is they dump to me like, well, here are all the changes. And I was like,
Yeah.
holy
Here's the pull
shit.
request.
Yeah. I was like, well, thank you, but like the comments are not as good. And usually, like, they just tell you, they are like a junior developer in that way. They tell you what they changed, like, literally. Like, here I added this parameter. I'm like, well, I can see that in the code, but I need the logic of, well, we added this parameter that will be used there, and that's why we did it, or we are reusing what already existed because of X, and that's what's missing. And your tool can be really, really good there. Not only for adding context to me, but I can see it adding context to the LLM itself. So I can see it iterating with your tool.
One of the coolest things we see, and we use Codex internally, but we see it with Devin and other, recursive background tasks. Um, so a guy, my co-founder, he's the CEO, and he likes to do front-end work because he can do it with Codex. So he wants to see something in the app, he just does it with Codex. And then Codex implements it, opens a pull request, Baz reviews it, and then Codex goes for a fixed round. And then we get better code without the CEO really learning the conventions here. It's really, really cool to see. And I hope
Yes.
the world gets this.
Yeah, you're clearly in the right path. Like that's where things are moving. For many people, it's the future, but for others, it's the reality today. Like you can already like go to buzz.co and then start like adding this in your PRs.
Yeah.
Perfect, Nimrod. So thank you very much. It was a pleasure.
Thank you, Jordy. Thank you very much.
I really hope people stop promoting every time that a new model comes. Their tool in your support.
Yes.
Have a
Yes.
really good day.
You too. Bye
Thank you,
bye.
Nimrod. Bye.